So sorry for the disruption. Actually, I didn't know what happened to it got itself. So I'm not sure whether that recording is available or not. Otherwise, I'll record it. Fine. So it's okay, but we have covered this one. Ninth question, this seventh question. These things we have covered. So yeah, we were in the last question. Has anybody solved? Question number 10.
I
I'm getting my code.
my parts I don't know, madam. That's I have to brush up my high school maths.
Okay. Well, Kushit, you got what is the answer?
5/4 I'm getting, ma'am.
How you are getting?
I have integrated m times sine 2m with respect to dm in this interval 0 to pi/2, and it has been divided by just integration of this given PDF.
Yes,
So
yes, yes.
I'm getting value pi/4.
So yeah,
In
you
the
know this
numerator,
FM.
in the numerator I'm getting pi/. Yes, ma'am. Yes, ma'am.
So you know this is the PDF. Then DM is 1. Consider probability density function given as sample. What is the optimal quantization level?
If we will integrate it within this given interval, then we will not get it.
Yeah. But yeah, overall the interval it will be 1 because it is a
No, madam. Only minus infinity to plus infinity it is 1, right?
Yes. But what if the probability density function defined only for that particular period? Suppose it is defined for this period. This is in journal. But yeah, because why it is the case? Because the sum of all the probabilities of all the events of a sample space, it is 1.
So yeah.
So this is the question. So what is that asking? Consider probability density function of the samples of a signal. Some signal is given, some signal is there where the sample is given by this density function from 0 to pi/2. Then what is the optimal quantization level corresponding to the interval 0 to pi/2? So yeah, let's solve. So what is the integration will get? Many students are joining today.
Sorry, ma'am.
So this is the case, right? Sorry, this will be multiplied by m, and this will be
Yes,
sine 2m.
This simply sine.
Yeah.
So
the bottom one will be 1, no? As per your.
No, it will be 1. We have to see whether it is 1 here or not. But if it is defined for that events only, for that interval only, then it should be 1. But I don't know whether it is defined for. Suppose this is the case. Let's see this. Suppose this is the case. Here it is given. It is following sine up to pi/2. This is pi/2. This is pi. Okay. So it is following like sine up to this pi/2. What if it is not following sine after this? We have a different function. We don't know what is there. So if it is only defined for this interval, then it should be 1. We have to check. So let's solve. This cos 2m divided by 2, 0 to pi/2. This is minus, right? It should be minus or plus. Sine cos minus only. Then what is the value you are getting here? Here first and second function we should consider. What is that? Algebra first function we have to take algebra, right? No, last. I also don't
First
remember.
function will be as it is, ma'am. First function will be as it is, and we will integrate the second function, then
No, no,
negative,
no, no. That
then
is also first and second we have to take
oh,
with priorities, right? There is some IQ or somewhat like
ma'am,
trigonometry
I
first
will
will
be
come.
outside. We will integrate the second function simply first of all.
No, yeah. What I remember, madam, in that first function as it is, and the integral of the second function
No, no, no.
by
I remember this U into V
no,
dV
yeah. There are different methods, but what we remember is
minus
yes.
integration of what is
Integration u dash into integral of v
uh,
integral of v dx.
dV, na?
Yes, ma'am.
dV.
Yes, ma'am. It will be dx, ma'am. It will be dx. Let's assume that there is some x variable. Both are functions of x variable. So, yes, ma'am. Now it's good.
Okay, okay. No, there is criteria for defining 1 and 2. Okay, let it be.
Yes, ma'am. If u dash becomes suppose one, so we will take m as first function
Yes, yes,
depending on
yes.
the complexity of the
dm
relative complexity.
minus 1 into what is this?
Minus cos 2m
Cos
by
2
2.
divided by 2. So here it will be 1 by 2. It will be
Mm-hmm.
plus. So dm.
Hmm.
So these things
Again, it will
actually
become sin 2m.
minus cos 2m by 2 plus 1 by 2. Here it is into plus
One,
sine.
4 sin 2m. Yes,
So
ma'am.
minus 1 here if we take minus 1 by 2 out, then cos pi minus cos 0 is 1. So yeah, it is 1 here also. You can see minus 1 minus 1. So that's why I was solving for you. Like it should be 1. We don't even need to solve it. So what is here? Minus 1 by 2 into minus 2. So we can see it is 1. And if we 1 by 2 sine 2m by 2 minus m. So this is the final expression you are also getting, question. Sine 2m by 2.
Man, sinusoid will become zero. You didn't put the limits there. When we will put the limit, it will become zero sinusoidal part.
Acha, 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 acha,
And
we
the
have
m part
not
will come
put.
out to be pi by 2. Pi by 4.
Okay, we have not put the limit till now. 0 to pi by 2. So
Sinusoid will be easily, it will become zero. So, rid of
yeah, yeah,
that.
yeah, yeah.
And m
So
will be pi.
minus pi by 2 minus 0 minus 0. Okay, so it is pi by 4. I'm getting minus pi by 4 by.
There will not be minus. It's a mistake actually. I think there has been some calculation mistake. It will not be minus.
No, that in the integration by parts, in you missed the first term,
Yes,
madam.
ma'am. Here in minus m
Ah,
cos
we missed
2m
that.
term.
hmm.
Here you have to put opposite limits first, or take care of this minus sign. That is why we are getting minus here.
Okay, okay, okay. Here. No, okay, fine, fine. Okay, fine. So we are getting pi by 4. You can check with the calculation. So, this is the procedure. How will you solve? Basically, this one. So you have to remember some basic calculus also. I also forget somewhat. So yeah, this is the 10th question. This was the 9th question. Actually, these didn't get recorded. So I will face issue associated with it. So I'll just tell. 9th question answer is diversity. And the 7th question mutually exclusive. The answer is second. 8th question is answer is what was the answer? This one. Then 6th we are getting 2 by 3. And these notes will be uploaded however in the link prescribed to us, so you can refer those. And this was all about some of the questions which I dealt. So yes, moving ahead, I'll just try to give some grips of probability for you. These questions, these are not clear, I think. So yeah, you know about binomial random variable, Poisson random variable on constant random variable. So I'll just some standard discrete distribution I'll deal with you.
Madam,
Yeah.
I think they are not there part of the week 11 or 12. I didn't see these
So
things.
what was the part of week 11 and 12?
Uh, 1 minute, I have gone through it. Random processes are there.
Hmm.
Wide sense stationary, power spectral density,
Okay, okay.
Gaussian random process. After,
Gaussian.
yeah,
Mm-hmm.
yeah. Generally, after Bayes theorem, he moved to after Bayes theorem and PDF, moved to Gaussian random variables.
No,
And
it's yeah. So the Gaussian at some point every the sum of the random variables will converge to Gaussian random variable. So it's okay. Common distributions. So you should know about the common distribution as well, but it's okay. So this is not of the part. So I will also not deal. It's okay.
I know this is a very important one, but
Yeah,
uh,
yeah, yeah.
I
For this,
covered it.
for this, and these questions are also not clear enough. Yeah. Can you solve this question? This is the question of populace. This is very tough question, I guess, if you can solve or not. So if you are not able to solve, just look at it and try to solve. This is one of the most common question for the interviewer. So
Okay, ma'am.
yeah, you please look at it and like which book you are referring for the probability? Are you preparing? Have you got any call, question?
And didn't yet receive any call. One of
So
my friends, she received call from ITBHU for
uh,
interview, but I am yet to receive a call.
okay, okay, okay. So like you have applied in many branches, right?
Yes, ma'am. Yes, ma'am.
So okay, yeah, maybe they are late to.
I will wait till the last. Till the last attempt.
Yeah,
Yes, ma'am.
nice, nice. So yeah, this is the very common question. If you can able to solve this, it's very good.
Let x equal to maximum of this, w is minimum of this.
Determine
It
this F Z and FW.
Okay, madam.
Madam,
I will try solving it later on. Actually,
Yeah,
right
yeah.
now it will be tired, so I
Uh,
can't do it
Madam,
enough.
yeah, yeah, yeah.
FZ, is it a PDF?
Yes, yeah,
Uh,
it's a PDF.
We have
So some basic concept is required for this.
1 minute, madam.
Yeah.
PDF or PDF is capital let some notation.
No, no,
Generally,
no.
PDF.
So what it is saying, this X and Y are random variables. Okay.
Yes, yes,
And we are defining this random variable as Z, some another random variable. Z
yes. Which
as
is
max of xy. So it will also have some distribution and w is equals to min of xy. It will also have some distribution. Then how this
yes.
distribution looks like. It's,
Okay.
and this is very important and common questions of interview.
Yeah,
So
yeah, yeah. Please, you can explain. Yeah.
yeah, yeah. So I'll explain using some concept because in this book, which I have captured the images, it is a populous book, a very famous book of probability, random variables and all. So
what is the name of this book, ma'am?
it's
Right.
it's populous. This is populous probability. You can type this and you will definitely get. You will easily get. It's not an issue. Hmm. So yeah. So if you, I'll just tell some basics. If we, this type of question come into the picture, you can easily solve. So you can see here, I was trying to in the blackboard. So first of all, this Z is equals to max of xy. So how will you calculate? First, whenever you are asked, you asked to calculate this PDF, then you go through the CDF, because CDF is what? CDF f of x, f of z. This is capital Z. This is small z. Then P of z less than equals to z. Then you know this is max of x y less than equals to z, and you know f of z, this is capital, this is small, this is of f of z. So this is the processor, and now you have to think about it, like how will this looks like. So we'll consider 4 cases. This is for calculating CDF. So max of xy less than equals to z. So what it implies? X comma y max is less than equals to some number. Suppose z is some number z. This implies x should be less than equals to z and y should be less than equals to z, which implies x should be less than equals to z and y should be less than equals to z. Why it is the case? Just analyze in your mind. What if x is greater than equals to z, and what if y is greater than equals to z? Because it is only applicable when both of the numbers will be less than equals to z. And here it is random variable. Random variable is what? Random variable is a mapping of the events to a sample space, or where the sample space is the real line. So we are mapping the outcome of an event to a real line number axis. So here this is the case. So now if you use this, P of x less than equals to z, y of less than equals to z, then only max of xy less than equals to z. Let us see with some example. Suppose 3 and 4 is less than equals to 2. Suppose this is the question. So this is not required because 3 is not equals to 2 and 4 is not less than equals to 2. Suppose 3 and 4 is less than equals to 5. So when it is the case, when 3 should also be less than equals to 5 and 4 is also less than equals to 5. So this is the question basically coming from the aptitude. So this is the case. Now this x and y, these are the two independent variables. So then this will be p less than equals to z multiply of p y less than equals to z. So this is what? P of x z, sorry, f of x z multiplication of f of y z. Am I correct? You know why it is the case?
Yes, ma'am. I don't remember exactly, but it was something like that.
Yeah.
Means that it is lesser than equal to this probability.
Once you get this, then you can also have this f of z. So this is the basic funda of differentiation of f of x of z, f of y of z. So in this book, they have considered with some of the examples, like if how the x will distribution looks like and y distribution will look like, at the end what the z distribution looks like. So these are some of the examples, but the only thing you have to remember is this one. Similarly for the minimum case, so yeah, so here if you have the max case with greater than equal to z, then you will have 3 conditions, because this can possible if these 3 can have one condition, and if it is minimum of greater than z, then you should have only one condition, and minimum of less than z you have 3 conditions. So what you can do, if you have maximum with greater than, so you can just use 1 minus wala concept. If you have minimum with that less than, then you can use 1 minus wala concept. So this is the basic funda, and this is the repeated question which is asked in Qualcomm interview also. So you can,
Okay. Okay.
yeah. So this is one of the question which. So I would like to know what are the concepts. Say you said one of the quantization, and other things.
1 minute, madam. So tomorrow, yeah, I would like you to summarize important concepts. Yes, quantization is one
Hmm.
concept you can cover, and
So I will just ask you to have a table in front of you with the Fourier series, Fourier transform, Laplace transform, Z transform, and
yes,
understand the
yes,
applicability of
I have made, madam. But the only thing is, I am trying to memorize. This omega domain 2 pi term comes. So which one to remember? Maybe you can give us some rules of thumb,
remember.
something.
Yeah, yeah. So I'll make a table on that. Definitely.
Which one easy to remember? Either in F domain or omega domain, so that we can anyway convert from that to this. But which is which is wise to remember? Omega domain formula or F domain formula?
Actually, F domain is a bit easier because it is to the point thing kind of thing. So I'll suggest
And
you
that
that.
sync function also, today I spent 2 hours trying to sketch the sync function and rectangular function pair with the correct formulas with omega domain, F domain. In different books we have showed different things. And some minus tau by 2 plus tau by 2, some is minus t plus t. Formulas are different, right?
So you just remember this thing. You will not have any issue with that.
And the sync definition also varies. Sync x is equal to, some books will show sin x by x, some books will show sin pi x
No,
by pi
no.
x.
This sync x is always equals to sine pi x by pi x.
No,
But
in
yeah,
some books,
sampling function is this sine x by x.
yes, some books will show sync as sin x by x.
This is sampling function. This is different. It is not sync.
Very
Yeah, confusing.
see, I know overall concepts, but when it comes to precise doing the sums, if you miss some pi, 2 pi, because in objective type, those are misleading. Okay, sometimes they'll give 2 pi. I know it must be one of it.
Yeah, one of it. Yeah, yeah. Very true. This, if you know this is A tau sync F tau, I only know this. And whenever it come ask me to convert it any point, then I can do. So how it will look like here, since it is, this is even. So this is A tau by 2 minus tau by 2.
Wait a minute. I note down. Okay, if it is a rectangular function of minus tau by 2 plus tau by 2 with amplitude A, sorry, with the height A pulse, then the Fourier transform is A tau sync F tau.
Yes.
F tau, the definition of sync here is sync of F tau is equal to pi F tau by pi F tau.
Yeah. Here it is. Sine of pi f tau divided by pi f tau. I'll draw this. What is the significance of this one? Tau by 2 minus tau by 2. If you know this one, this is from the duality.
Yes, the duality property also, when I try to substitute, we should get the same thing.
Yeah. So if you know, remember this is more than enough. A tau sync F tau. Just the differences with the triangle one. Tau minus tau. This is A. A tau 6 square F tau. Here the width is 2 tau. Here the width is tau. So what I'm asking you to remember, just one thing. This is area of the rectangle, and this is
Yes.
pulse width.
Pulse width of tau.
So the amplitude part of the sink will be area of the rectangle, and the f should be f, and then along with that pulse width. And here the pulse width is twice. Sorry, pulse width by 2. Pulse width
Yeah.
by 2, or it is area. So
Go back to the sink function, madam.
Yeah,
Sink
yeah.
function. Here on the right hand side, bottom right hand side, the rectangular, that width is the frequency, right? Minus tau by 2 plus tau by 2.
Yes, yes, yes.
Frequency in hertz. Okay. Frequency in, yes. Okay. Minus tau by 2 plus tau by 2 A.
So here also it is area. Here also it is tau pulse width. So sink will be same. The area and the pulse width will be there. Along with how you can characterize the rectangle. You can characterize the rectangle using the area as well as pulse width. That's it.
So the duality property also works. Simply substitute instead of F T.
Why this duality property works here? Because it is an even function. So what is happening with the y-axis? The content after positive and negative is same. So it is working.
But the actual formula for duality is small x of minus f, right?
Yeah. To say it is same here.
Because of even function, that minus is the discounted. Yes.
Yeah. Since it is minus t tau, which is equals to a tau sink t tau. Because even function has this one, t is equals to s.
And the sink of 0 is 1, right? Sink of 0.
It is area here. So if you plot this one, suppose a tau sink f tau. So you can write this.
Suppose f tau is
A tau, sir. A tau.
yes.
So f tau, pi f tau.
Yeah.
So let's plot this.
So if f is 0, then sink of 0 is 0.
No. How will you do this as 0? This will come as limit.
Lower side. Differentiate both and put tau equal to f equal to 0.
Yeah, f is equal to that's okay. L hospital's rule. But whatever it is, we can say sink of 0. How do you calculate using L hospital? There's a difference. Sink of 0 is 1. Can I say that?
Yes.
Sink of 0 is 1.
Yes.
Yes.
Yeah, it will be 0 because it will be 1 because 0 by 0 L hospital will be there.
Yeah.
So if we plot this is very important this function, because in practice you have seen, we always see with this rectangular pulse. So you have done the digital communication. So have you heard of this raised cosine pulse?
Yes, that is a sink function.
Yeah. So instead of using this rectangular pulses for pulse code modulation or all, we use raised cosine pulse. Why? Because in the time domain, if you use sink in time domain, it has bandwidth of practically infinity, but it is leading to bandwidth of omega some finite quantity bandwidth in the frequency domain. Since the spectrum is very expensive, so we pass this raised cosine pulse in time domain so that we will get finite bandwidth in frequency domain.
Oh, okay. That means instead of sending a square pulse, we send a cosine
Yes,
We say
yes.
sync pulse.
Which is called race cosine pulse.
Okay, raise cosine. Can you write what raise?
This is raised cosine.
Okay, okay. Basically, cosine pulse.
Yeah, yeah,
But why cosine pulse? It is sine pulse, right? The sync only, right?
yeah. In ideally it is the bandwidth of this one, but we take only up to this, I think.
Oh, okay, okay.
So sorry, time duration,
Yeah.
so that we can have the better bandwidth utilization
Okay,
and frequency
okay.
domain. So this is there. So that's why we study in signals and system about this race sync, so that we can easily apply that there in communication system.
Okay. So we never send square pulses. We send only raised cosine
Yes, yes.
pulse.
Mm-hmm. Because it will lead to infinity bandwidth at in frequency domain.
Yes.
So if we plot this, this is f. So suppose f is equals to 1. So if we consider frequency transform, a is equals to 1, suppose it is also 2, so tau by 2 is equals to 1. Okay, so pulse width of 2 we are considering and area is 1. Then if it is pi, f is equals to pi, let's calculate the value. So area is 2, so area is equals to 2 always. Then sine pi into, so frequency we have to consider not in pi, we have to consider 1. It is 2. This is pi into 1 into 2. So if f is equals to 1, this is 1. So what I'm trying to say, the sync function will have the values at 0 with integer multiplication, only. So let's see, this is 2 sine 2 pi divided by 2 pi. So this 2 pi is 0. Okay, so 0. Similarly 2, 3, 4, at every integer multiplications, the sync function will be 0. Suppose this is fz, this is f.
1 by tau, 2 by tau, 3 by tau, right? In the frequency. Then this
Sine
will
pi f tau is equals to sine n pi. So pi f tau is equals to n pi. So pi will cancel. F is equal to n by tau. So yeah, if you have this at this functions, n is the integers 1, 2, 3, 4. So if you have these frequency, then sync function will be 0. It is tau. Okay, got it. So this is suppose 1 by tau, 2 by tau, 3 by tau, 4 by tau, minus 1 by tau, minus 2 by tau, minus 3 by tau. So this is the case with the same function. So if we see the content of this course, so that the content of this course consists of first lecture, So I will deal with lecture by lecture. So please let me know about some of the topics.
Yes, madam. Yeah, I have made summary sheets.
Summary sheet you have made for every lecture.
Every lecture I've gone through one sheet I have made. But only to remember the formulas.
Okay.
But conceptually, I find that tough to understand is that Hilbert transformer Westwich
Okay, that's very
is
interesting.
tricky. That is tricky. Thing that comes in Westwich modulation, right? Hilbert
Yes,
transformer,
yes, yes.
complex pre-envelope.
Hilbert transform.
Yeah. Actually, madam, yeah, it's not difficult, but everything is a mathematical treatment only.
Very true. So your exam is on 29th, right?
Yes.
Okay. So I'll just suggest everything, this GraphStore concept. You just go through the assignments
Yeah.
twice, thrice. You will be easy to pass. It's not a day.
So concepts only FM demodulation. PAM. PAM. Okay, PAM versus impulse sampling versus PAM sampling.
Actually, okay. Mm.
Okay, see, madam, no problem. I just understood for interview sake, for doing problems. This is where the problem comes. We will say 1 by 2 pi sigma, 1 by 2 pi multiplied by integral, they do like that
Uh-huh. Hmm.
objective type. Because I tell you where, see, okay, of course. So I have another problem. So I'm doing another course also, signals and systems.
Abhishek Thakur is taking.
So I have to juggle in my mind time domain, frequency domain, Laplace domain, Z domain, and all formulas look like the
So
same.
this time you are taking two courses. You are doing two courses.
Yes. So
Okay.
sometimes XN, sometimes XFT and XFT and duality and duality is there in Z transforms
But
also.
it's very good that you are doing these two courses, related courses together at time.
Yeah,
So
but fortunately, the same, Aditya sir. So it is uniform. He treats the same way. Okay,
mm-hmm.
uniform.
Next.
Actually, sir, actually, the signals and is a very tougher than I find that communications.
And
Because a lot of concepts are involved in the signals and systems.
a lot of problems also arises. Like
Lot of problems. And in communication, primarily to sum up, communication is all about only modulation only. Most of the time is modulation.
yes, yes, yes.
Modulation, demodulation, and then quantization. Quantization.
Quantization, modulation, demodulation, and
That's all. That's all. Nothing else.
uh, yeah, this some of the probability concepts. That's it.
Probability, that's okay. That is ancillary, but the core course is about modulator, demodulation, and sampling quantization. The three concepts. But in signals and systems is a very rich. There are lots of all transforms you have to understand. See, conceptually, there is only a time domain signal, and then time domain signal to frequency domain signal. Frequency domain signal, you express use Laplace transform continuous. In discrete, use Z transforms, and then we come into the important topic of filters. Everything is a filters.
Yeah,
Filter,
the sir has covered this filters as well.
the filter structures are all covered. I find that is more more.
Yeah, but the filters are not a part of gate syllabus, I guess. Mm.
So, yeah, sometimes this convolution, yes,
This combination also. Yeah.
convolution and circular convolution. We have to remember the procedures. See, my problem is I lost touch with the pen and paper doing math work long back.
Mm.
So I can answer in the interview, but doing the sum now somewhere suddenly ask me convolve two signals x of t and h of t, and they give xn and yn and convolve. And I know there is a procedure, shift left and sum or something like
Yes,
this.
yes, yes,
Okay,
yes.
but to do that it requires a patience. And
Uh,
somewhere I fumble, I make a mistake. And the worst thing is in objective type, two things will be similar. Okay.
yeah, very
So,
true. Question, you want to have any topic specifically?
No, ma'am, no such topic, but I will be attending the session. It will be around 6 p.m. only.
Yeah, yeah, yeah. I think message.
I will be attending the session, but I don't have any such a specific topic.
sir, madam, what I will do is I will again prepare things which I need clarification in
Just
communication.
mail me.
Yeah, sure, sure, sure.
Like you mailed me before, because that session was very good. I think that negative frequency and all. So it is required to have that type of
And
knowledge.
madam, just like that, another confusion I have is I think it is not related to this left hand signal, right hand signal. It's not, I think it is signals, right?
Okay, left hand or right
Left hand
hand?
signal, right hand signal. Yeah, I'm sorry, that is part of signals and systems.
Okay, okay. I think Abhishek Thakur session is there.
Yeah, that's also there. That's also there. I'll ask her. I'll ask her.
Yeah, yeah, yeah. I'll just say once to him. Okay, then I think we should wrap it up. So thank you both of you for joining the sessions. I think Kushit was consistently joining session from first class to 12th class. Thank you so much for joining. And sir, to you also, like you have done so many courses, and it's very good to interact with you. So thank you. We'll meet tomorrow.
Okay, madam, even in dreams also I'm getting all that symbols, delta, t part, integral sigma, e to the power of minus.
Yeah, it's good.
Last 1 month, every day I try to look at it and try to recollect and try to convert, intuitively try to feel what they are doing. So my mind also, dreams also, I get e to the power minus s, e to z to the power.
E power minus is working. Nice.
Everything is e power, right? Complex.
Yeah. So if you can make a comparison table between all the transformations, then it's
Yeah,
very
so
good.
that is my goal. I'll make it. Thank you.
And you can just stick it in your wall, so you don't have any issue with that. So okay, thank you so much.
Thank you.
Yeah.